Have you ever been confronted with large amounts of information at once? It can be an overwhelming experience. How do you make sense of everything? With Power BI, you can create data models that act as visual representations of your records. However, this requires familiarity with the process and mastery of many different techniques. So, we've designed this course to equip you with the skills you need. Data modeling is creating visual representations of your data in Power BI. You can use these representations to identify or create relationships between data elements. By exploring these relationships, you can generate new insights into your data to improve your business. Microsoft Power BI is a fantastic tool for creating data models and generating insights. And you don't need an IT-related qualification to begin using it. This course is designed for anyone interested in learning about building data models. It also establishes a strong foundation for those pursuing a career in data analytics. By exploring Power BI, you learn how to create data models using schemas and relationships, analyze your models using DAX, also known as data analysis expressions, and optimize a model for performance in Power BI. In the first week of this course, you'll explore the key concepts related to data modeling. You'll learn to identify different types of data schemas, like flat, star, and snowflake. You'll create and maintain relationships in a data model using cardinality and cross-filter direction. And you'll learn to form a model using a star schema. The second week of this course focuses on DAX, or data analysis expressions. This syntax is used to create elements and perform analysis in Power BI. You'll start by writing calculations in DAX to create elements and analysis in Power BI. You'll explore the formula and functions used in DAX and use DAX to create and clone calculated tables. You'll then be introduced to the concept of measures. You'll learn where measures are used and what types are available. You'll work with measures to create calculated columns and measures in a mode. And you'll learn about the importance of context and DAX measures. Finally, you'll perform useful time intelligence calculations in DAX for summarization and comparison, and learn how to use these techniques to set up a common date table. In the third week of this course, you'll learn how to optimize a model for performance in Power BI. You'll begin by learning how to identify the need for performance optimization. This means analyzing your data models to determine how they can perform more efficiently. You'll then learn how to optimize your Power BI models for performance. You'll explore different techniques and methods for ensuring that you're running efficient models, and you'll also learn how to optimize performance using DAX queries. In the final week of this course, you'll undertake a project and graded assessment. In the project, you'll build and optimize a data model for AdventureWorks. You'll have to build this model from scratch and optimize it to run efficiently. Finally, you'll have a chance to recap what you learned and focus on areas you can improve upon. Throughout the course, you'll engage with videos designed to help you build a solid understanding of data modeling in Power BI. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then consolidate your knowledge by consulting the course readings, and measure your understanding of key topics by completing the different knowledge checks and quizzes. This will set you on your way towards a career in data analytics and form part of your preparation to take the PL-300 Microsoft Power BI Data Analyst exam. By the end of the course, you'll be equipped with the necessary skills to work effectively with data models in Power BI. Good luck as you start this exciting learning journey. As a data analyst, you'll often manage thousands, hundreds of thousands, or even millions of records. But how can you generate insights from all this raw data? You can convert it into data models. In this video, you'll explore the basics of data models and learn how to create them. Over at AdventureWorks, the company needs to generate insights and increase sales from different data sources. These data sources include customer, sales, and marketing data. But these data sources are all in separate locations, and the only way to generate insights is to combine them. That's where the data model comes in. AdventureWorks can integrate its data sources as a data model in Microsoft Power BI, then generate insights in the form of visualizations. Let's find out more about data modeling and learn how AdventureWorks can make use of it. At its core, data modeling is creating a structured representation of data. This representation can then be used to support different business aims. In other words, a data model shows how different data elements interact, and it also outlines the rules that influence these interactions. Data models can be built in Microsoft Power BI. Microsoft Power BI is software that provides data analysts with a user-friendly interface for building data models. Other benefits of a Power BI data model are that it can be used to define relationships between tables and assign data types. You can also create calculated columns and measures, and update your model as your business requirements change. In Power BI, the foundation of creating reports and dashboards lies within the data model. It's important to understand how to design a data model that effectively aligns with the visual elements within your reports and dashboards. There are several steps involved in building a data model in Power BI. Connect to your data sources, prepare and transform your data, and configure table and column properties. Then create model relationships. And finally, create measures and calculated columns using DAX, or data analysis expressions. Once your data model is in place, you can analyze the data to generate insights to help you achieve your business objectives. Let's explore some examples of how data models can be applied to business data. By optimizing the data model, you can significantly improve the performance of your Power BI reports and dashboards. It's also easier to aggregate structured data in a data model, thanks to the clear relationships and hierarchies. With an effective data model, you can perform more advanced analytical capabilities, like complex measures and predictive analysis. When your underlying data is structured, organized, and aligned, your insights and reports are more likely to be accurate and reliable. Now that you understand more about data models, let's briefly explore how AdventureWorks can build one with Power BI to generate the sales insights they need. First, AdventureWorks needs to connect to its data sources by executing a query in Power Query Editor. The result is then loaded into the Power BI data model as a table. Using Power Query in Power BI, AdventureWorks can finish importing and cleaning their data sources. This creates a data model that contains cleaned customer, date, employee, and marketing data as separate tables. Each table in the model represents a specific business entity, and each table also has its own related attributes. The next step is to define the relationships between the tables in Power BI's model view. The company can link its customers and sales tables using the customer ID column, which is common to both tables. With this relationship, the company can now view each customer's transactions. AdventureWorks could also link its sales and marketing tables to understand which campaigns were most effective for boosting sales. Finally, the company needs to create measures and calculated columns using DAX, or data analysis expressions. DAX is a syntax used in Power BI to analyze data. You'll learn more about it later in the course. For now, just know that AdventureWorks can use DAX to create aggregations and custom calculations to generate insights on important aspects of their data, like sales totals. A strong understanding of data models will help you maximize your data's full potential. Building sophisticated data models creates a robust foundation for data analysis and generating insights. Remember that your data model is the foundation of everything else. Generating business insights often means working through large amounts of data, and it's important that this data is stored and structured meaningfully. With Power BI, you can structure your data using a schema. In this video, you'll learn about different types of schemas and their advantages and disadvantages. AdventureWorks wants to optimize its inventory and rework its sales strategy to sell more bicycles. But first, it needs to analyze the relevant data to determine the best way to approach this task. These data sources include customer, product, and sales data, along with information on other aspects of the business. AdventureWorks can use a schema in Power BI to organize and build relationships between these different data sources. This way, the company can generate its required insights. Let's find out more about schemas and how AdventureWorks can use one. A schema refers to a structure that defines the organization and relationships of tables within a dataset. It represents the logical framework of how the data is organized and connected. There are many benefits to using a schema in Power BI, which you'll explore over the course of this lesson. A schema plays a crucial role in defining the data structure. It also enables efficient data analysis, helps with the creation of visualizations, and assists with generating meaningful insights from your data. There are 3 different types of schema that can be used to organize and structure data: a flat schema, a star schema, and a snowflake schema. Let's review each of these schema types and find out how AdventureWorks can use them. A flat schema is the simplest form of a data model. All attributes and fields related to the entity are stored in a single table. As you discovered in earlier courses, a table is a set of rows containing data, with each row divided into columns. Each column represents a piece of information with a specified data type. The required attributes and entities are stored in the rows and can be extracted as required from the columns. There are several advantages to a flat schema. It's easy to retrieve data from, it's less complex to analyze flat schema data, and it's a simpler way to visualize data. However, even though it's an easy approach to understand, the flat schema still has a few disadvantages. It requires large datasets, which are difficult to maintain and slow to query. It leads to data redundancy and inconsistency, so is more suited to smaller datasets. And it doesn't allow for complex datasets which require more flexibility and detail. Next, let's explore the star schema data model. A star schema is a more advanced approach to structuring and organizing quantitative or measurable data in Power BI. It allows for multiple tables to be connected through one central table. In a star schema, a central fact table connects to multiple dimension tables. You'll explore these concepts in a later lesson. These connections look like a star shape, so it's called a star schema. AdventureWorks can build a star schema using a central fact table that contains sales transactions. The company can then link the fact table to dimension tables that contain records for customers, employees, dates, and marketing campaigns. Let's break down the components of the star schema using the example from AdventureWorks database. First, there's the fact and dimension tables. You'll explore these further in a later lesson. And there are the table relationships. There are many different types of relationships, which you'll also explore in a later lesson. A star schema offers many advantages over a flat schema. By storing data in separate tables, star schemas help to reduce data redundancy and boost query performance. It also provides a clear logical data model, which makes it easier to understand the data structure. However, it's also less flexible than other schema types. Adding or modifying tables can require extensive changes to the schema, and the star schema can struggle to manage complex relationships. Next is the third and final model, the snowflake schema. A snowflake schema is an extension of the star schema. It breaks down the dimension tables into multiple related tables. Existing tables in a star schema can be further denormalized into other tables, which creates a hierarchy. Yet these tables maintain a relationship with the dimension and central facts tables. For example, AdventureWorks can further normalize its product data into supplier and category data tables. Don't worry about the terms normalize and denormalize for now. You'll learn more about these concepts later in the course. Extending a star schema into a snowflake schema offers several advantages. It provides more efficient data storage and retrieval. It improves data integrity and consistency, and it reduces data redundancy. It also offers scalability and flexibility by integrating new data tables as required. Yet there's also disadvantages to a snowflake schema. It's more difficult to perform data analysis because of the extra relationships. These new relationships also make the schema more challenging to understand and manage, and they result in slower queries. Finally, it's important to validate your schemas to make sure they're accurate. When validating a schema, you need to check for the following. Make sure each table column has been assigned the correct data type, like text and numeric. Check that each column has the correct formatting applied. Confirm that all columns have clear descriptions with relevant context, and make sure all table and column properties are correctly configured. You should now be familiar with the different types of schemas in Power BI and their advantages and disadvantages. You can build on this knowledge to develop robust data models in Power BI. This way, you'll ensure that your data retains its integrity and simplicity and can be used to generate insights. As you discovered in an earlier lesson, you can use schemas for data organization. And two central components of all schemas are fact and dimension tables. In this video, you'll explore these tables in more detail and learn how they can be used to build schemas. AdventureWorks is dealing with an increase in delivery errors. To help fix this issue, the company needs to explore its data and discover the underlying cause. It can use fact and dimension tables to find a resolution. As you learned earlier, a schema is a logical and visual representation of how your fact and dimension tables relate. They're the backbone of schemas in Power BI. Fact tables are called fact tables because they consist of the measurements, metrics, or facts of a business process. In other words, they hold quantifiable, measurable data. Let's take the example of an AdventureWorks fact table. It sits at the center of a sample AdventureWorks star schema. It's called Sales Orders and includes transaction details like Order ID, Product ID, Customer ID, Quantity, and Total Price. These are core facts about transactions, like the customer who made the purchase, the price of the product they purchased, and so on. And this fact table is related to dimension tables. Dimension tables are typically textual fields and provide descriptive attributes related to fact data. They offer the context surrounding a business process event. In the AdventureWorks star schema, the dimension tables are linked to the fact table and include date, customer, sales, and product data. These are descriptive details that can be used to identify individual customers. These two examples should help you understand how fact and dimension tables inform the building of a schema. In the star schema model, the fact table sits at the center. The dimension tables radiate out like the points of a star. Each dimension table is directly connected to the fact table. For example, the sales order table is the central fact table in the AdventureWorks star schema. The dimension tables like date, customer, and product are connected directly to it. This structure simplifies queries because you only need to navigate through two tables to answer questions like, what were the total sales on a particular date? And these fact and dimension tables can also be used to extend a star schema into a snowflake schema. A snowflake schema makes use of dimension tables by normalizing them. Normalization means that existing tables within a schema are divided into additional related tables. This technique creates a structure that resembles a snowflake. This is where we get the name snowflake schema from. For instance, in addition to a central fact table, AdventureWorks product dimension table could be split into a product table, connected to subcategory and category tables. This schema reduces data redundancy, but adds complexity to queries. You can help AdventureWorks use these schema designs to discover the cause of the delivery errors. You can import the required data sources, represent the data sets as a snowflake schema, and perform data analysis. Your analysis might reveal that the errors are linked to inventory management issues or incorrect addresses on record. With these insights, AdventureWorks can fix its delivery processes and avoid future errors. You should now understand the importance of fact and dimension tables when building a database schema. With these tables, you can create different schemas that help to organize and make sense of your data and generate insights. You'll often have to untangle large datasets and make sense of the relationships between tables. An understanding of cardinality and table relationships can be useful in these situations. In this video, you'll explore the concept of cardinality and review the different relationships that can be created between tables in a database. To help with its business planning, AdventureWorks asks questions of its data, like what bicycle sells best in each region, or what is the revenue of each store. However, the data required to answer these questions is stored across several tables, posing a complex data analytics challenge. AdventureWorks can solve this challenge using cardinality and by identifying the table relationships. Before we find out how AdventureWorks can solve its data issues, let's take a few moments to explore the concept of cardinality. In the context of data analytics, cardinality refers to the nature of relationships between two datasets. In other words, how tables in your database relate to each other. It's important that your cardinality settings are correct. Incorrect settings can lead to inaccurate data analysis and flawed business decisions. There are three types of cardinalities, or relationships, between tables in Power BI. The first is a one-to-one relationship. In this instance, a record in one column of table A corresponds to a unique record in one column of table B. One-to-one relationships are less common in data modeling, but they are useful when dealing with specific scenarios. For example, a single business entity can be loaded as two or more model tables because the data might come from different sources. This scenario is common for dimension tables. For example, in AdventureWorks dataset, each bicycle model has a unique model ID listed in the product ID column, and a separate table lists specific features for each model ID in a product features column. Together, these columns form a one-to-one relationship between the two tables. Next is the one-to-many relationship. Each record in a column of table A corresponds to multiple records in a column of table B, but not the other way around. AdventureWorks lists its stores in table A, and it lists the employees of each store in table B. The relationships between the stores and their employees establish a one-to-many relationship. This is because each employee works for one store, but each store has many employees. This is the most common type of relationship in data modeling, where one table acts as the primary table, and the other tables act as related tables. Finally, there's the many-to-many relationship. This is where multiple records in a column of table A are related to multiple records in a column of table B, in both directions. Many-to-many relationships are often used to establish a relationship between two fact tables, or two dimension tables. In the case of AdventureWorks, a customer can purchase many different bicycle models, logged in table B, and each bicycle model can be purchased by multiple customers, recorded in table A. This creates a many-to-many relationship. Understanding these relationships and configuring your settings appropriately helps your queries and calculations flow correctly and generate accurate insights. Another important aspect when considering the cardinality of your data is granularity. Granularity refers to the level of detail or depth of a dataset. The granularity of your data should align with the business questions you need to answer. For example, AdventureWorks wants to view customer purchase histories over the past year. With data granularity, you can explore individual transactions to analyze individual customer behavior and identify purchase patterns. However, if you want to understand which specific bicycle models are performing well in a region, you need sales data with high granularity. High granularity data is the dataset that captures detailed information about the transactions. For example, geographical sales of products can be captured as a continent, country, state, city, and all the way down to individual stores. But for a more general analysis, like total sales per store, a lower level of granularity suffices. Low granularity data refers to the dataset that captures a high-level summary, or an aggregated level over broader categories. An example of this is monthly sales of a product category. The sales data is summarized at the category level, but only on a monthly basis. Understanding the granularity of your data is crucial for establishing correct cardinality. It also influences how you set up your cross-filter direction in Power BI, which you will learn more about in a future lesson. But be careful when judging the required level of granularity. Misjudging the level of granularity can lead to misrepresented data and incorrect business insights, and excessive granularity can lead to too much data and slow down your queries. By developing a keen understanding of cardinality and granularity, you can untangle complex data scenarios, like the one at AdventureWorks, with confidence and ease. Different datasets are explored at different levels of detail, depending on the questions to be asked. Answering these questions requires working with different levels of data granularity. Over the next few minutes, you'll explore the concept of data granularity, and discover how it can help inform your data analysis. Over at AdventureWorks, the company needs sales data to help make strategic decisions about what products to stock. It must identify the highest and least performing products using annual and daily sales data. You can help the company generate these insights by using data granularity to analyze its sales records. Let's begin by recapping what is meant by the term data granularity. As you might recall, data granularity refers to the level of detail or depth captured in a certain dataset or data field. Granular data provides deeper and more precise insights. This delivers more nuanced and valuable findings. Remember, data granularity isn't about always having the highest level of detail. It's about having the appropriate level of detail. Before you begin your analysis, ask yourself, do you require high granularity or low granularity? The decision should depend on the specific requirements and objectives of the analysis. It's about striking the right balance between detail, manageability, precision, and simplicity. High granularity data is the dataset that records very detailed information about each transaction. This level of granularity provides a comprehensive overview of each transaction, including specific attributes and metrics associated with the transaction. Let's look at an example from AdventureWorks database. For instance, in AdventureWorks data analysis, product-related data can be captured as product ID, category, subcategory, name, price, size, and weight. Some benefits of high granularity include in-depth exploration of trends, patterns, and relationships within datasets to identify specific behaviors and anomalies. The flexibility to aggregate and summarize data at various levels of detail, and the ability to facilitate accurate decision-making by drilling down into specific data points. Next, let's look at low granularity. In low granularity data, information is captured and analyzed at a high-level summary or an aggregated level. The data is not broken down into individual records. Instead, data is summarized over broader categories or periods. Here's an example from the AdventureWorks database. For example, AdventureWorks can explore its sales quarter by business quarter or month. The benefits of low granularity include a simplified view that's easy to understand and allows for analysis without an overwhelming level of detail, improved performance, and reduced data volume, which leads to faster query execution, and a quick identification of trends and patterns for informed decision-making. Let's take a closer look at data granularity and its role in data analysis. In the context of data analysis, high granularity data is often more desirable. It offers a finer level of detail, so it provides greater precision and potential for deeper insights. For instance, tracking sales hourly, high granularity, instead of monthly, low granularity, could reveal patterns like peak shopping hours during the day. However, working with high granularity data comes with its challenges. The more granular your data, the larger your datasets will be, potentially slowing down data processing and analysis. On the other hand, low granularity data, while offering less detail, can provide a broader view of your data. It's also easier to manage because of the smaller datasets. In AdventureWorks, the monthly sales data, low granularity, could help identify broader trends, such as seasonal sales fluctuations of certain product lines. For example, bicycle repair equipment sells more during the spring and summer months. This is because customers are more active on their bicycles. You can ensure the relationships are accurate and produce consistent aggregations by matching the granularity levels. It also helps with correct filtering and supports drill-down analysis. Data granularity also has a significant impact on building relationships between tables in Power BI. For example, to determine the highest and lowest selling products in the AdventureWorks inventory, you must produce reports of total sales and budget over time using the sales and budget data. The sales data is in the sales table and has daily level granularity. On the other hand, the budget data is stored in the budget table and is monthly. To establish the relationship between tables and produce accurate results, you need to format the date table in both tables, and then build a relationship based on a commonly formatted date column. Understanding and manipulating data granularity is a powerful skill that all data analysts must master. The degree of granularity can impact the insights drawn and the ease with which data can be analysed. With a firm understanding of data granularity, you can now approach your data analysis tasks with a refined perspective. It's time to discover the story that the right level of detail in your data can tell. Untangling complex, intricate data is often too large a task for one individual. Thankfully, a Power BI star schema can simplify complex data. Over the next few minutes, you'll learn how to configure a star schema in Power BI, including differentiating between fact and dimension tables and configuring cardinality and cross-filter direction. AdventureWorks needs to organize its data to understand what products have been ordered and where they need to be shipped. You can help them to organize the data using a star schema. But first, let's review the steps for setting up a star schema in Power BI. The first step is to disable auto-detect. Power BI auto-detects relationships when you load multiple tables. You need to disable the function so you can set your own relationships. The next step is to load your fact and dimension tables into Power BI. Select the required tables from your Excel spreadsheet or other relevant location and load them into the application. Once you've loaded the tables, you must create relationships between them. You can join tables by dragging relationships between key columns or from the Manage Relationships section of Power BI Desktop. Finally, you need to set cardinality and cross-filter direction. You must set cardinality to determine how your database tables relate, and you need to set the cross-filter direction to determine the pathway through which filtering occurs between your tables. Now that you're familiar with the steps for setting up a star schema in Power BI, let's help out AdventureWorks. As you've just discovered, the first step is to disable the auto-detect function. Launch Power BI Desktop. Go to File and select Options and Settings. Then, select Options within the Settings menu to open the Options dialog box. On the left bar of the dialog box, select Data Load. Then, deselect Auto Detect New Relationships after data is loaded and select OK. Next, you need to load your fact and dimension tables into Power BI. Select Home, then Get Data. Select Excel Workbook from the list of options in the Get Data drop-down menu. Navigate to the AdventureWorks Company Data Spreadsheet and select Open. The Navigator menu appears on screen. This menu displays a list of available tables within your spreadsheet. You can select which tables you need from this menu. You can also use the search bar to locate a table when working with larger spreadsheets. A preview of each table appears in the preview pane when selected. In this instance, you require the Product, Region, Sales, and Salesperson tables. Select these tables, then select Load. The tables are now visible in the model view. Your next step is to create the relationships between the tables. You must build a one-to-many relationship between the Sales table and the Product, Region, and Salesperson tables. In this instance, you can create a relationship between the Product table and the Sales table based on the Product key column, which is common in both tables. Similarly, you need to relate the Sales table to the Region and Salesperson tables based on the Sales Territory key column and Employee key column, respectively. Alternatively, you can also create and configure relationships from the Manage Relationships section of Power BI Desktop. From the Model view, select Manage Relationship. Select New to open a dialog box called Create Relationship. From here, you can build and configure relationships. Select the Sales table from the drop-down menu, then select the Product key column from the available options. Then select the Product table and its Product key column. Next, you need to set up the cardinality and cross-filter directions. To set up cardinality, select the Cardinality drop-down menu. Then select the appropriate relationship type. In this case, it is many to one. Finally, under the Cross-Filter Direction drop-down menu, select the filter direction. Power BI's default direction is single, so leave this as it is for the current scenario. However, before you select a bidirectional cross-filter, make sure that you fully understand its implications. Select OK when finished. You can repeat this process to create relationships between the other tables. Select New, then work through the same steps again to create more relationships. Select OK from the Create Relationship dialog box when finished. Then select Close from the Manage Relationships dialog box to return to the model view. The star schema is now ready to use. The sales table is the fact table. It sits in the middle of the model and connects to the salesperson, region, and product dimension tables. You should now be able to configure a star schema in Power BI, differentiate between fact and dimension tables, and configure cardinality and cross-filter direction. Keep the data analysis needs of your organization in mind as you build and refine your star schemas. With practice, this powerful data modeling technique will become a vital tool in your data analysis toolkit. Data is not always structured in a way that provides quick insights, but by leveraging the Snowflake design schema, you can unlock your data's full potential. In this video, you'll explore the Snowflake schema, learn how to build your own, and discover how to transition to one from a star schema. AdventureWorks data is stored in a complex format. It's having difficulty retrieving the necessary information. You can help AdventureWorks build a Snowflake schema to enable more efficient data storage and make it easier to generate insights. Let's begin with an overview of the Snowflake schema. The Snowflake schema is a type of database schema design that optimizes data storage and retrieval by normalizing the data into multiple related tables. Unlike the star schema, which uses denormalized data with fewer tables, the Snowflake schema consists of a central fact table connected to one or more dimension tables. The dimension tables are further connected to other related tables to create a hierarchy. For example, the AdventureWorks Sales Datasets Product Dimension table has a product category and a product subcategory. In a star schema, all three fields exist in one dimension table. However, in a Snowflake schema, you can split this single table into three different tables, and all these tables are related to one another via one-to-many relationships. Now, when you filter a specific product category, the filter is propagated through the tables from product category to subcategory, product, and then sales. As the AdventureWorks example has just shown, the Snowflake schema offers many benefits. So, it's an ideal choice for complex data structures in Power BI. Here's a quick overview of some of these benefits. It simplifies dimension tables by splitting them into separate tables. Simplifying dimension tables also improves data integrity because hierarchical relationships more accurately represent the data. And splitting data sets into separate tables also helps to reduce data redundancy because each attribute is only stored once. It also enhances data analysis because a more efficient structure means more accurate insights. And finally, a Snowflake schema leads to better management of data using hierarchies. Now that you've explored the basics of the Snowflake schema and its benefits, let's help AdventureWorks build one. Before uploading the dataset, you first need to turn off Power BI's Auto Detect feature. This feature automatically creates relationships between the tables, but you need to do this manually. To disable this feature, open Power BI Desktop, select File, Options and Settings, and then Options within Settings. This opens the Options dialog box. Select the Data Load option to the left of the dialog box. Then deselect Auto Detect New Relationships after data is loaded. Then select OK. Now you can load the AdventureWorks dataset. From the Home tab, select Get Data. Then select Excel Workbook from the options in the drop-down menu. Navigate to the dataset and select Open. The Navigator menu presents a list of available tables from the dataset. Select the following tables: Category, Product, Region, Sales, Salesperson, and Subcategory. Then select Load. The tables are loaded into Power BI and presented in the model view. You can now establish the relationships between the fact and dimension tables. You can do this by dragging the primary key from the dimension table to the foreign key in the fact table. For example, drag the product key column from the product's dimension table to the product key column in the select fact table. You can then repeat this process for all related tables in the Snowflake schema. Next, you must create hierarchies in the dimension tables to enable greater data analysis. Create relationships between the product table and the category and subcategory tables based on the category ID and subcategory ID respectively via a one-to-many relationship. This creates a hierarchy of product dimensions. But what if AdventureWorks has already created a star schema? Let's review the process for transitioning from a star to a Snowflake schema. Open the Power BI project that contains the star schema. Your first step is to normalize the dimension tables. Identify the tables in the star schema to be further normalized into related tables. Create separate tables and then link them using foreign and primary keys. To create these tables, you'll need to use DAX. You'll explore DAX in greater detail in a later module. For now, let's just use some basic DAX code. Select the Table Tools tab, then select New Table. Add the required DAX code to the formula bar to create a new category table. Repeat this same process with the required DAX code to create a subcategory table. Once you've created the new tables, Power BI attempts to detect the relationships between them. Remove any new relationships that it establishes between the tables. Next, you need to update the product hierarchy in the dimension tables to reflect the new Snowflake schema structure. Build a relationship between the category and subcategory tables based on the subcategory ID. Then build new relationships between the product and category tables based on the category ID. You can now use this hierarchy to interrogate data on individual products, product categories, and product subcategories. Configuring the Snowflake schema in Power BI is a valuable skill. By mastering these skills, you can play a critical role in helping organizations make data-driven decisions, optimize operations, and drive growth. Congratulations on reaching the end of this first week in this course on data modeling in Power BI. This week you've explored concepts for data modeling. Let's take a few minutes to recap what you've learned in this week's lessons. You began the week with an introduction to data models. You learned how to identify the initial steps involved in data modeling, like defining relationships between tables, assigning data types, and creating calculated columns and measures. You then explored the process steps for building a data model in Power BI. This involves connecting your data sources, preparing and transforming your data, and configuring the table properties. You also learned how to create model relationships and create measures and calculated columns with DAX. And you reviewed the benefits of data models. You discovered that data models can be used to enhance the performance of reports, improve calculations, improve analysis and insights, and deliver more accurate reports. You then explored schemas. A schema is a structure that defines the organization and relationships of tables within a dataset. 3 types of schema can be used to organize and structure data. The first is a flat schema. This is the simplest data model form. It's a set of rows and columns containing data. Then there's the star schema. It's a central fact table that links to multiple dimension tables. These tables are connected through relationships. And finally, there's the Snowflake schema. This is an extension of the star schema. It breaks down dimension tables into multiple related tables. You first learned how to set up a flat schema. This involves removing duplicate data, formatting columns, and editing the table's properties. In the lesson exercise, you configured a flat schema for AdventureWorks. You also completed an activity configuring a flat schema with multiple sources. Finally, you completed a knowledge check to test your understanding of data models. And you reviewed links to materials for further learning in the Additional Resources item. The next lesson focused on cardinality and cross-filter direction. This lesson began with an introduction to fact and dimension tables. Fact tables hold quantifiable, measurable data on a business process. It sits at the center of a star schema. Then there's dimension tables. Dimension tables provide descriptive attributes related to fact data. They radiate out from the central fact table. A Snowflake schema extends this design. It normalizes the dimension tables by breaking them down into additional related tables. Next, you explored the concept of cardinality. Cardinality refers to how your database tables relate to one another. Your cardinality settings must be correct to ensure your insights are accurate. There are 3 types of cardinality in Power BI. The first is a one-to-one relationship. In this instance, a record in one column of Table A corresponds to a unique record in one column of Table B. Next is the one-to-many relationship. Each record in a column of Table A corresponds to multiple records in Table B, but not vice versa. This is the most common relationship. Finally, there's the many-to-many relationship. This is where multiple records in a column of Table A are related to multiple records in a column of Table B, in both directions. You can understand these relationships using cross-filters. Power BI offers single cross-filter direction and bidirectional filtering. Single cross-filter direction is the default setting. It propagates from one table to another, as in Table A to Table B, but not the other way. Bidirectional filtering is filtering against the direction of a relationship. This means changing the direction of the filter to both, so you can propagate the filter in the reverse direction. Another important aspect of cardinality is granularity. Granularity refers to the level of detail or depth of a dataset. The granularity of your data should align with the business questions you need to answer. Do you need high granularity data in the form of a dataset that captures detailed information about the transactions? Or low granularity data in the form of a dataset that captures high-level summary or at an aggregated level over broader categories? You then tested your understanding of these concepts. You completed a knowledge check to test your understanding of data models. And you reviewed links to materials for further learning in the Additional Resources item. In the 4th and final lesson, you learned how to work with advanced data models. The lesson began with an introduction to setting up a star schema in Power BI. The key steps in this process involve loading the required tables, creating the relationships between the tables based on common keys, and setting up cardinality and cross-filter direction. You then completed an exercise configuring a star schema for AdventureWorks in Power BI. And you compared your result against an exemplar. Next, you learned how to set up a snowflake schema in Power BI. The process steps are like those for setting up a star schema. The key difference is that you must create hierarchies in the dimension tables to enable greater analysis. You can also convert a star schema into a snowflake schema using DAX queries. You then put this knowledge into practice by changing an AdventureWorks star schema into a snowflake schema. You continued your exploration of advanced data models with snowflake schemas. You reviewed the importance of snowflake schemas, including their key benefits, and you explored the process for resolving challenges in data models. Finally, you completed a knowledge check and module quiz to test your knowledge of the concepts you encountered. You've now reached the end of this module summary. It's time to move on to the discussion prompt, where you can discuss what you've learned with your peers. You'll then be invited to explore additional resources to help you develop a deeper understanding of the topics in this lesson. Best of luck. We'll meet again during next week's lessons. What if you're analysing a data model and the data you need isn't in the original model? If it's possible to derive the data from the original model, you can use DAX, Data Analysis Expressions, to create custom calculations to generate the data. In this video, you'll learn about DAX and explore the basic syntax of DAX formulas. AdventureWorks needs to identify its top-selling products and calculate its revenue. But these insights are beyond the scope of the original data model. They can only be generated by calculating the existing data. So, AdventureWorks must use DAX, or Data Analysis Expressions, to complete this task. Let's begin with an overview of DAX. DAX is a programming language used in Microsoft SQL Server Analysis Services, Power Pivot in Excel, and Power BI. It is a library of functions, operators, and constants used in formulas or expressions to create additional information about the data not present in the original data model. With DAX expressions, you can create custom calculations on data models to extract maximum information from your data to solve real-world problems. To master DAX, you need to understand its syntax, different data types, the operators, and how to refer to columns and tables using functions. Let's begin with the syntax. DAX usually computes values over columns in a table, so you need to know how to reference a column in a table. First, write the name of your new calculation. Then add the equal sign operator. Next, write the name of your DAX function. Then parentheses that contain the logic of your formula. Write a table name enclosed in single quotes, followed by the column name enclosed in square brackets. Omit the table name if the reference column is on the same table. Let's demonstrate this using an example from AdventureWorks. The AdventureWorks sales table doesn't include any data that denotes the total number of products sold. The company could generate this data using DAX. In the DAX expression, sales is the table name followed by the column name quantity to be referenced, and sum is the DAX aggregation function. Total products sold is the name of the new calculated column that holds the results of the calculation. When executed, this DAX formula adds a new column to the existing table that contains the required data. Next, let's review operators. DAX formulas rely on operators. There are many different types of operators. They can be used to perform arithmetic calculations, compare values, work with strings, or test conditions. Some commonly used operators in DAX include parentheses for grouping arguments, arithmetic operators for performing basic functions like addition and subtraction, and comparison operators for comparing values. DAX also uses logical operators to return true-false values, and concatenation operators to combine two or more values into a single string. AdventureWorks can use operators in a DAX formula to calculate its total revenue. In this example, the multiplication operator multiplies the unit price by the quantity to compute the total revenue. The parenthesis group the arguments of the expression, and the SUMX DAX function adds the arguments' values to calculate the total revenue. Finally, let's move on to DAX functions. DAX functions perform various calculations, manipulate data, and create custom expressions. As you discovered in an earlier example, AdventureWorks need to calculate their total revenue, and they can perform this calculation using the SUMX DAX function. For now, you just need to be familiar with the concept of functions. You'll explore functions in more detail later in this lesson. It's also important to understand that DAX is not just about formulas and functions. It involves understanding the data model, the relationships between tables, and the context in which calculations are made. For instance, understanding how the tables relate to one another in AdventureWorks' data model is crucial for creating meaningful calculations. There are several important aspects of a relationship that will help you to understand DAX. Tables connected via a relationship are not the same. They are either on one or many sides of the relationship. Columns used to build the relationship are the keys of the relationship. The column on one side of the relationship needs to have unique values, and tables relationships can be either single or bidirectional. The direction of the relationship determines the direction of automatic filtering. Remember, mastering DAX requires practice. Start with simple formulas and gradually incorporate more complex functions and operators. And ensure you understand your data model and the relationships within it. As your comfort with DAX grows, so will your ability to turn data into meaningful insights. Eventually, you'll be able to unleash the full potential of your data using DAX and gain valuable insights for decision-making. As a data analyst, you'll often have to perform complex calculations on large datasets beyond the scope of spreadsheet software, like Microsoft Excel. In these instances, you need to utilize formulas and functions in DAX. In this video, you'll review some commonly used DAX functions and examples of formulas that use these functions. AdventureWorks has experienced steady growth in recent months. However, this growth has led to data management issues, so AdventureWorks needs a better way to generate insights into its data. Fortunately, DAX formulas and functions are the perfect solution for generating these insights. Let's find out more about DAX formulas and functions and then discover how AdventureWorks can make use of them. You previously learned about operators, the building blocks for creating a DAX formula. However, there are also many common formulas and calculations performed on data. These are part of DAX's extensive library of functions. Functions are reusable pieces of logic that can be used in a DAX formula. These functions can perform various tasks, including aggregations, conditional logic, and time intelligence calculations. Data analysts can use these functions to handle complex data challenges and drive meaningful insights. To create a function, you must be familiar with the syntax. A function begins with the function name, followed by parentheses containing the function's parameters. DAX function names are typically expressed using capital letters to help differentiate them from table and column names. For example, AdventureWorks could use a function to get the distinct count of rows in the custom key column in a table named sales. DAX expressions can be difficult to write, particularly complex calculations which require nested functions. So, you can use variables in your DAX formulas to simplify calculation results and store them for reuse. You can use variables to store intermediate results in a temporary location. They're like a storage box that you can put information into to be retrieved later. This improves reliability and readability and reduces the complexity of your expressions. You can define a variable in DAX by placing var before your variable or expression. Follow the variables with return, where the expression's result is provided. AdventureWorks can create a simple formula that defines two variables to generate insights into its sales and customer data. Sales amount and customer number are variables defined to determine the total sales and number of customers, respectively. The return statement divides one variable by the other. The entire expression's result is in the DAX query's return statement. Although DAX functions can be classified into many broad categories, there are some commonly used functions. Let's review these and discover how AdventureWorks could leverage them to resolve their business problems. The calculate function evaluates an expression in a context modified by the specified filters. AdventureWorks can use the function to analyze total sales for a product category based on the color of the products. The company just filters the products based on a specified color like blue. The calculate function evaluates the sum of the sales table sales amount column in a modified filtered context. A new filter is added to the product table color column. Another useful function is average x. The average function returns the average of an expression evaluated for each row in a table. AdventureWorks can use this function to calculate the collective average for freight and tax. The function calculates the average freight and tax on each order in the sales table. It first sums freight plus tax amount in each row and then averages those sums. You also need to be familiar with the summarize function. The summarize function creates a summary table by grouping data based on one or more columns. AdventureWorks can use the summarize function to generate a sales summary report displaying annual sales for each product category. This function returns the summary of sales grouped around the calendar year and the product category. The resulting table allows you to analyze the sales by year and product category. DAX is a powerful language for advanced data modeling and analysis. Its wide range of functions can be combined with formulas to generate deep insight. And remember that DAX functions can be combined to create complex calculations that perform multiple operations. This versatility and flexibility makes DAX an essential tool for data analysts. DAX is a useful language for generating business insights using formulas. However, data analysts need to understand that DAX generates insights from data based on the context of that data. In this video, you'll explore the concepts of row and filter context and discover how they impact data evaluation in DAX. AdventureWorks needs to answer business-specific questions like, what are the total sales for each product? And what are the top selling items by category. It can generate these insights using DAX. DAX formulas answer these questions by evaluating the relevant data according to its row and filter context. Let's find out more about the relationships between DAX and context. DAX computes formulas within a context. The evaluation context of a DAX formula is the surrounding area of the cell in which DAX evaluates and computes the formula. This surrounding area is determined by the set of rows and filters to be evaluated in a DAX expression. It determines which subset of data is used to perform calculations. DAX expressions adapt or refer to the context for evaluating dynamic and context-aware results. Let's begin with an overview of row context. Row context refers to the table's current row being evaluated within a calculation. When a DAX expression is evaluated for a specific row, it considers the values of the columns in that row as the context of the calculation. This allows for calculations to be performed at row level, and it's especially useful for iterating through rows within a table. For instance, if you create a formula for a calculated column, the row context for your formula includes the values from all the columns in the current row. Let's demonstrate the concept using AdventureWorks sales table. The table contains sales data for multiple products over 1 month, stored within the following columns: date, product, category, quantity, and price. AdventureWorks wants to create a total sales calculated column that shows the total sales data for each product in the table. The company can use a DAX formula to multiply the quantity data in the quantity column by the price data in the price column for each item. The formula iterates through the relevant quantity and price column values at the row level and returns the results in the total sales calculated column. In other words, the formula calculates the new values via row context. Next, let's review filter context. As the name suggests, filter context refers to the filter constraints applied to the data before it's evaluated by the DAX expression. In the previous example, a different result was produced in each cell because the same DAX expression was evaluated against different subsets of data. However, with filter context, you can determine which rows or subsets should be included or excluded from the calculation. Let's demonstrate filter context using the AdventureWorks sales table. AdventureWorks must calculate the total sales for all items in category X. The company can create a DAX formula containing filters that target all sales recorded against category X. Once the formula is executed, it iterates through each row and retrieves only the data with the value of X. Row and filter context also interact with each other to produce results. When a DAX expression is evaluated, it first considers the filter context. Then the row context takes effect. Let's demonstrate how this occurs with AdventureWorks. The company can use the filter context to narrow its sales data to the selected region. The row context then iterates each row in the filtered results and calculates the sales totals. As you've just discovered, a filter applied on a table column affects all table rows, filtering rows that satisfy that filter. If you apply 2 or more filters to columns in the same table, they are executed under a logical AND condition. This means only the rows satisfying all the filters are processed by the DAX expression in that filter context. Be careful when applying a filter in a large data model with multiple tables. A filter context automatically propagates through the relationships between the tables in the data model based on the selected cross-filter direction of the relationships. In this example, this means that when data is filtered in the sales order table, then data in the related tables is also filtered. You can disconnect the tables to prevent propagation. A row context, on the other hand, doesn't automatically propagate through a data model's relationships. If you have a row context in a table, you can iterate the rows of a table on the many side of a one-to-many or many-to-many relationship using the related table function. You can also access the rows of the parent table using the related function of DAX. Understanding the context of DAX expressions at the row and filter level is important as you continue to build data models for reporting and visualization. Context affects how DAX interprets and analyzes your data, so always consider the context when creating and executing your DAX formulas. You might often encounter tables that don't have the data you need. You can generate this data by combining existing columns to create a new calculated column. In this video, you'll explore the basics of calculated columns in Power BI, learn how to create them using DAX, and evaluate their effectiveness in contributing to meaningful analysis. AdventureWorks is analyzing the data in its sales table and realizes there's no data for the profit margins on its product categories in the original data source. Calculated columns are the perfect solution to this problem. AdventureWorks can add data on its profit margins using DAX expressions to create new calculated columns within the original data source. Before you begin helping AdventureWorks, let's find out more about calculated columns. A calculated column is a new column added to an existing data table in Power BI. Data analysts can use calculated columns to derive new data from existing columns and add it to the data model. Once added, these columns can be used in any part of a report or visual, just like any other column. Traditional columns are filled with data imported from a data source. A calculated column is created by defining a DAX expression. You can create a DAX expression that calculates the data from two or more columns. The result of this calculation is then added to the table as the newly calculated column. Write the name of your calculated column and an equals operator. Then write the names of the tables to be referenced in single quotation marks and their respective column names in square brackets. Include a relevant arithmetic operator depending on the operation required. For example, AdventureWorks can create a total sales calculated column by multiplying the quantity and unit price columns in its sales table. Now that you've explored the purpose of calculated columns in Power BI, let's help AdventureWorks to calculate its profit margin from its sales data in its sales table by creating calculated columns. Launch Power BI Desktop and load the AdventureWorks dataset. The workbook contains one table, called Sales. The table tracks AdventureWorks' recent sales data. Access Power BI's Data View to view the sales table. AdventureWorks need to calculate its profit margin, but to do this, it must first calculate its total sales for the quantity of each item sold. However, the table is missing this data. You can add this data to the table by creating a new total sales column. You just need to multiply the quantity and unit price columns. Select the sales table from the data pane on the right-hand side of Power BI Desktop. In the Table Tools tab, select the New column from the Calculations group. This opens the DAX formula bar. Write DAX code in the formula bar that multiplies the quantity column by the unit price column and adds the result as a new total sales column. Press Enter to execute the code. A new total sales calculated column appears under the sales table in the data view on the right-hand side of the Power BI interface. You can use this new column in any report or visualization like any other table column. Now that you've identified the total sales data, you can create a profit column to determine how much profit has been made on each item. Write another DAX formula that subtracts the cost from the total sales and generates the data as a new profit column. Press Enter to execute the formula. The new profit calculated column is added to the sales table. Now that you've identified the profits, you can create the profit margin column. Select New column again, then write another DAX formula in the formula bar that divides the profit and total sales columns and generates the result in a profit margin calculated column. Press Enter to execute the formula. The profit margin column is added to the data. Finally, you need to format the calculated columns. Select the profit column and format it as currency. Then format the profit margin column as a percentage. You should now understand the basics of calculated columns and be able to create them using DAX and evaluate their effectiveness. Measures uncover the information hidden in your data and help you to tap into its real potential. Over the next few minutes, you'll explore measures and their importance for data analysis. You'll also explore how calculated tables are built from pre-calculated measures. AdventureWorks needs to calculate its sales data for all the products it has sold this month. It also needs to ensure that this calculation can be updated monthly against new sales data. The company can generate these insights using measures. You can discover more about measures and how they function by exploring how AdventureWorks uses them. Let's begin with an overview of measures. Measures in Power BI are used to perform calculations on data model fields. Measures play a pivotal role in data analysis and interpretation. Measures are used in Power BI to perform aggregations, calculations, or evaluations on data that provide meaningful insights. Measures are typically used in data visualization elements. Examples of these elements include charts, tables, and cards. By using measures, you can compute aggregated values such as sums, averages, minima, maxima, counts, or more complex statistical calculations. Measures in Power BI offer several benefits in data analytics and reporting. Let's explore some of the benefits. Measures are calculated in the context of the visualization or report they are used in. This means they are dynamically updated based on filtering and other interactions within the report. In other words, if the context changes, then so does the measure. This dynamic calculation allows you to dive deeper into data and gain insights from different angles and perspectives. Measures are also reusable. Once created, you can continue to recall them in your code. This reduces the repetitive work of creating the same calculations and ensures data consistency across all reports. Another benefit is performance. Measures can be used to track the performance of different aspects of a business. Measures are commonly used to create key performance indicators, or KPIs, essential to monitor business performance. KPIs provide a quick snapshot of performance against predefined targets or benchmarks. And finally, measures also help to maintain consistency. Measures help maintain consistency in metrics across different visualizations and reports. Consistency ensures the same results show regardless of filtering or grouping. In your measures, your calculations must be standardized and uniformly applied throughout the analysis. This ensures accurate and reliable reporting across various visualizations and dashboards. Measures can also be used to create calculated tables in Power BI. A calculated table is a table that you add to a model derived from existing tables by using a DAX formula. AdventureWorks has created a measure called total sales. This measure is the sum of all sales across all products. Now the company needs a new product table that lists each product alongside its respective total sales. This can be done using a DAX formula. In this DAX formula, sales is the original table, sales product is the product column in the original table, and total sales is the measure AdventureWorks created. Let's take a moment to explore a sample of the syntax used to create such a formula. Begin with the name of your new measure, followed by an equals operator. Then add the required expression that contains the logic of your measure. For example, AdventureWorks can create a new measure called total sales that calculates the total sales amount from the sales table. When executed, this DAX formula will list each product and its total sales. Creating calculated tables from pre-calculated measures is particularly useful for creating a summary table from large datasets, or for creating a table with data that does not exist in the original tables. This can enhance data analysis visualization capabilities in Power BI. In this video, you have learned about measures and their importance in data analysis. You are also able to explain how calculated tables are built from pre-calculated measures. Measures in Microsoft Power BI are essential to data analysis and interpretation. They offer dynamic, reusable, and complex calculation capabilities, enabling businesses to gain insights from their data and make data-driven decisions effectively and efficiently. As a data analyst, you want to be able to provide your business with answers and solutions to the questions they are asking. Using measures, you can gain valuable insights into your data, drive strategic decisions, and enhance your business's performance. Over the next couple of minutes, you'll explore the different types of measures in Power BI. AdventureWorks is using different types of measures to prepare its annual sales report. To compile this report, it must analyze its sales data across different regions and generate insights into specific products and sales team members. let's explore the different types of measures AdventureWorks can use to prepare its report. Before we explore measures, let's quickly review the concept of additivity. Additivity refers to how measures behave when aggregated across different dimensions. For example, summing or averaging values. However, not all measures behave the same way. So, understanding the behavior and categorization of measures is crucial for accurate data analysis and visualization in Power BI. Measures are essential for performing quantitative analysis and deriving meaningful insights from the data. They provide a way to summarize, calculate, and compare data across various dimensions based on specific criteria and business requirements. Measures can be categorized into three types: additive, semi-additive, and non-additive. Let's explore these types of measures in more detail. Additive measures facilitate data aggregation across any business dimension, like time, geography, or product categories. The basic mathematical operations applied to these measures are addition and subtraction. These types of measures provide consistent results, regardless of how you group data. Additive measures also use the sum DAX function to aggregate over any attribute. For example, AdventureWorks' monthly sales analysis report shows revenue and quantities sold by product category and region. This data is for a specific unit of time, in this case, per month. You can use additive measures to aggregate revenue and quantities sold by summing them across all dimensions. This allows you to view the total revenue and total quantities sold while analyzing the performance of various products, regions, and months of the year. Next is non-additive measures. Non-additive measures cannot be meaningfully aggregated across any dimension. These measures involve calculations like ratios, averages, and percentages. The result of aggregating a non-additive measure can be skewed or misleading and should be handled with caution. For example, at AdventureWorks, the average sales per customer is a non-additive measure. The average sales per customer in January is $300, and in February, it's $350. However, it doesn't make sense to add these averages and state that the average sales per customer for the 2 months is $650. Instead, calculate the total sales and total numbers of customers for the 2 months combined. Then divide the total sales by the total number of customers to obtain the correct average sales per customer for the period. Finally, let's explore semi-additive measures. Semi-additive measures can be aggregated over some, but not all dimensions. They're mostly used in situations where the data represents a state at a particular point in time. They've meaningful aggregation for certain dimensions, but not for all. Like with additive measures, semi-additive measures use sum to aggregate over some dimensions, and a different aggregation over other dimensions. Examples of semi-additive measures that AdventureWorks use include inventory balance and current account balance. AdventureWorks has created a measure called inventory at hand. It uses this measure to add inventory across different product categories or store locations. But the measure can't be used to add up the inventory across time, like the change in inventory over a 2-month period. This is because it's semi-additive. For example, AdventureWorks had 50 bicycles in stock at the end of January and 60 at the end of February. But it would not be accurate to say that it had 110 bicycles in stock for the 2 months. The stock level changed over this period. It wasn't a fixed unit or measurement. You should now be able to identify and distinguish between the different types of measures in Power BI. Each of these measures plays a unique role in generating insights and guiding decision-making. As always, with data analysis, it is vital to remember that the value lies not just in the numbers, but in their correct and thoughtful interpretation. Do you want to create custom calculations for tables, columns, and measures? You can create custom calculations by using DAX. Over the next couple of minutes, you'll learn about context and how it impacts DAX measures. You will also examine different scenarios where measures are presented in various ways. AdventureWorks wants to analyze its sales data, determine which customers make the largest purchases, and compute stock in hand across all stores in an inventory management scenario. At this stage of the course, you should be familiar with the concepts of DAX measures and contexts. You'll often create measures in the form of custom calculations, but these custom calculations are context sensitive. It's important to understand the influence of context because it can result in variations in your calculations. These variations are based on the level of data you are evaluating, the model structure, and the visual you are using to represent it. An understanding of context and variation helps deliver accurate data analysis and provides business intelligence to key stakeholders. Let's recap the basics of context. Context in DAX comes in two primary forms: row context and filter context. Row context is the current row being evaluated in an expression, like racing bikes in the AdventureWorks dataset. In contrast, when you build reports in Power BI, you can filter the report data, which results in DAX using the filter context. This is the subset of data the calculation operates upon, influenced by visuals or reports filters. For AdventureWorks, it could be all cross-country bicycles sold in North America. Now let's explore the impact of context on DAX to understand how the use of context in DAX measures can influence business decisions. AdventureWorks wants to analyze and present a report on annual total revenue. The company can use the sum x DAX formula to compute the sum of all the quantity values multiplied by the unit price in the sales table. By applying this measure to the sales table, the formula computes the sum of all sales amounts. But this measure utilizes only the row context. AdventureWorks needs more insights to drive key decisions through data. For example, it must understand which products are selling the best to improve warehouse stock management and impact marketing decisions. To identify the best performing product categories, AdventureWorks can filter the dataset using a DAX query. This query determines the total sales for products under the bikes category. It incorporates filter context created by the category column from the product table in addition to the row context. It incorporates filter context created by the category column from the product table in addition to the row context. AdventureWorks also needs to determine which customers make the largest purchases. First, the company must determine the average purchase amount using the average DAX function. It can calculate the average sales amount per customer by applying this measure to the sales dataset. To compute the measure for the customer with the highest purchases, you need to define a logic based on customer ID. Customer ID corresponds to the total sales amount of $2,000 and above as high purchase customers. And those who spend less than $2,000 are average purchase customers. In this case, the customer ID is now acting as a filter context to compute the measure. This instructs the sales and marketing team which customers to target in their campaigns. You should now be familiar with the impact of context on DAX. The context-sensitive nature of DAX is a powerful feature of Power BI. It enables dynamic calculations based on the context in which the DAX computes the formula. Understanding how context impacts DAX allows users to create more accurate, insightful, and dynamic reports that can be tailored to specific business scenarios. Power BI is very effective for generating insights, but writing DAX code to analyze data takes time. Fortunately, you can create calculations and measures faster using Power BI's Quick Measures feature. Over the next few minutes, you'll explore the concept of quick measures, learn about the different types available, and review the process for creating them in Power BI. AdventureWorks wants to quickly analyze and monitor the performance of its sales team against several key performance indicators. But constantly rewriting the same DAX code for each performance review is time-consuming. AdventureWorks can speed up the process using Power BI's Quick Measures feature. Let's learn more about how Quick Measures work in Power BI, so you can help AdventureWorks. As you've just learned, Quick Measures are a useful technique for performing commonly used calculations quickly and easily. A quick measure runs a set of DAX commands behind the scenes, then presents the results as a new measure you can use in your reports and visualizations. In other words, you don't have to spend time writing DAX code. The measure does it for you based on the inputs you provide. There'll still be times when you need to write DAX expressions for specific business case scenarios, but quick measures can still act as a good foundation. Many different categories of DAX calculations are available to work with, and you can modify these calculations to meet your specific analytical needs. When creating quick measures in Power BI, you can choose calculation types depending on the nature of the analysis you want to perform. Types of quick measures include aggregate per category, filters, and time intelligence. There are also totals, mathematical operations, and text. Quick measures in Power BI offer several benefits for data analytics and reporting. You can use quick measures to generate commonly used calculations with just a few clicks. This eliminates the need to write DAX expressions, making the process more efficient. Another benefit is accessibility. You can create quick measures using Power BI's user-friendly interface. This accessible UI means even users with limited DAX knowledge can create calculations. Quick measures also help with data. They empower business users to take ownership of their data analysis and reporting. This simple and accessible tool for creating calculations reduces dependency on data experts. And quick measures also offer flexibility to iterate and refine calculations. If you need to adjust a calculation or explore alternative metrics, you can easily modify your quick measures without affecting the underlying data. Now that you're familiar with the basics of quick measures, let's help AdventureWorks use them to track the performance of its sales team. Before we begin, let's quickly review the model. You've launched Power BI, connected to your data sources, and loaded, transformed, and configured the following tables for your model: products, region, sales, and salesperson. Now you can begin creating measures in Power BI. The first step is to select the report view or data view to access the calculations group. Within this group, select Quick Measure. The Quick Measures window appears on the screen. Choose the required calculation type and fields to run the calculations. Alternatively, you can select the ellipses next to the table name on the data pane. Then select New Quick Measure from the drop-down menu. Remember that the measure is created by default in the table you have selected from the data pane. On the right side of the window, choose Select Calculation. This action opens a list of available calculation types in Power BI. AdventureWorks must calculate what quantity of each product each team member has sold. So, choose Total for category, filters applied. Next, you must select the required fields from the right pane to perform calculations. Select the Sales column from the Sales table and assign it as the base value. Then select the Category column from the Product table and assign it to the Category section. Then select Add to add these elements to the measure. The new quick measure appears in the Fields pane, and the underlying DAX formula appears in the formula bar. AdventureWorks also needs to know how much revenue each team member has generated this year. You can calculate this using a year-to-date sales measure. To create this sales measure, you can repeat the same process as before. Select Quick Measure from the Measure Tools tab, then select the Year-to-Date Total calculation type. Then select the Sales column from the Sales table as the base value, and the Order Date column from the Product table in the Date section. Finally, select Add. A new measure called Sales YTD appears in the fields in the data pane. Thanks to your help, AdventureWorks can now quickly track the performance of its sales team using quick measures. And you should now understand the importance of quick measures, be familiar with the different types available, and be able to create them in Power BI. Measures are Power BI features that let you explore your data to create meaningful reports and visualizations. In this video, you'll learn how to create custom measures with DAX. AdventureWorks needs to analyze its sales data to calculate its total sales and identify the top 2 best-selling products in each category and region. You can use DAX calculations to create custom measures to help AdventureWorks generate these insights. Custom measures refers to user-defined calculations or metrics created using DAX. Like traditional measures, custom measures also generate insights about data. Let's create custom measures to help AdventureWorks generate insights into its sales data. Before we begin, let's quickly review the company's data model. You've launched Power BI, connected to your data sources, and loaded, transformed, and configured the following tables in the model: products, region, sales, and salesperson. So, within our model, the sales table is the fact table. It's connected to all other tables via a series of active one-to-many relationships. And the cross-filter direction is set to single for all relationships. We're now ready to start creating measures. The first step is to create a new measure called total sales using DAX. In the Data view of Power BI, select New Measure from the Table Tools tab to expand the DAX formula bar. Type Total Sales as the name of your new measure. Be aware that any new measure added to the DAX formula bar is named Measure by default. If you don't rename the measure, all new measures are named Measure 1, Measure 2, and so on. Give your measures unique names to be easily identifiable, particularly when creating several measures. Write the total sales measure using the SumX function to multiply the unit price and quantity columns from the sales table. When you enter your formula, a list of suggested functions appears after you type the equals operator. You'll need to ensure that you understand the functions on this list and that you select the relevant one for your calculation. And once you reference a table or column name, Power BI displays a drop-down list of available tables and columns within your data model. Select the correct field when choosing a reference from the drop-down list to ensure your chosen measure functions as required. Press Enter to execute the function and generate the new total sales measure. You can view the new measure within the table you selected under the data pane on the right-hand side of the Power BI desktop interface. Next, you must create a measure that identifies the number 1 and number 2 top-selling products in each category. You can use the total sales measure to create another new custom measure. Select New Measure to expand the formula bar and write a measure called Top 2 Products. The measure begins with a variable that defines the ranking of products using the DAX values function. The Return section returns the value with the required calculation. The Calculate function filters the results of the total sales measure based on the top 2 products. The Top-In function defines the top products based on their respective sales. It uses the number 2 to represent the top 2 products. This is a dynamic measure that you can use to present the number 1 and number 2 top-selling products by product category, color, or region. Press Enter to execute the function. When executed, the function displays the results of the measure in a matrix or table that shows the total sales amount for the top 2 performing products in each category. You can dig deeper into the data by working through different business years. Thanks to your help, AdventureWorks now have the insights they require, and you should now be able to create custom measures with DAX. This is a valuable new skill you've learned. When used correctly, you can deploy dynamic calculations to generate insights quicker. There may be times when you encounter a data model with the cardinality and cross-filter direction configured, making it impossible to perform the necessary filters. With the cross-filter function, you can change the cross-filter direction for a specific measure while maintaining the original settings. In this video, you'll develop an understanding of the cross-filter function, its syntax, and its relationship to measures. AdventureWorks needs to analyze its sales performance for the previous few years, along with the performance of its sales team. However, its data model tables are connected via one-to-many relationships and single cross-filter direction. This prevents the company from filtering the data as required, and changing the cross-filter direction to both results in a permanent change. Fortunately, AdventureWorks can use the cross-filter function to alter the direction while maintaining the original settings. Let's explore how this works. As you've just discovered, the cross-filter function changes the cross-filter direction between 2 tables for a specific measure while maintaining the original settings. In other words, it specifies the cross-filtering direction to calculate a relationship between two columns. So, how do you create a cross-filter function? A cross-filter function can only be used within a DAX function that accepts a filter as an argument. Like the calculate function, for example, this means that the function receives two arguments: the name of the table you want to filter, along with the required column, and the direction in which you want to filter. Let's explore an example. The syntax begins with the cross-filter function. The argument is then placed in parentheses. The argument is the name of each table, followed by the names of the required columns in square brackets. The first column name is typically the many side of the relationship, and the second is the one side. Finally, add the filter direction. The first column name is typically the many side of the relationship, and the second is the one side. For example, AdventureWorks could filter between both sides of the relationship on its sales and products table, using the product key columns common to both. You might be familiar with cross-filter directions from earlier in this course. Here's a quick recap of the possible directions in which you can filter the relationships in your model. You could use none, which means that no cross-filter occurs within the relationship. There's also the one-way direction. Filters applied on one side of a relationship propagate to the other. However, you can't use the one-way option with a one-to-one relationship. Next is one-way right filters left. In this instance, filter propagation occurs from the right side to the left side of the relationship. And finally, there's one-way left filters right, in which filter propagation occurs from the left side to the right side of the relationship. Let's review an example of how AdventureWorks can make use of cross-filter function. In the AdventureWorks data model, the sales fact table is related to the dimension tables via one-to-many relationships and single cross-filter direction. This means that filters propagate from the product table to the sales table, but not in the other direction. So, when AdventureWorks analyze products sold by year, the results aren't accurate because the model can't filter the results correctly. You could try to resolve this issue by changing the cross-filter direction between the tables to both. But this also changes how the filters work for all data between these tables. Instead, you can create a cross-filter function using DAX to change the filter only for the current measure. Create a new product by year measure that computes the total number of products sold. The distinct count function calculates the number of distinct values in the product key columns between the sales and products tables. And the cross-filter function alters the cross-filter direction from single to both based on this column. Once AdventureWorks analyzes the measure based on the year column from the date table, the results are accurate according to the business analytical needs. You should now be familiar with the cross-filter function and how it works. Cross-filter is a useful function to change the direction of a relationship without changing the relationship itself. This function creates visualizations with custom filtering depending on the business needs. You'll often create measures that generate answers to specific data questions. But what if you need your measure to answer another question? You can use the calculate function to refocus your measure. In this video, you'll learn how the calculate function can alter the filter context for measures. AdventureWorks needs to analyze its total sales for all its products. It also needs to generate more granular data, including sales of bikes, blue-colored products, and sales within the US region. It can calculate the total sales for all products using a standard measure, but insights into the other data will require more specific filters. AdventureWorks can use the calculate function to change the filter context and generate these insights. Let's learn more about how quick measures work in Power BI, so you can help AdventureWorks. Changing the context of a filter means changing the data that the filter must analyze. For example, AdventureWorks needs to create a calculation or measure that analyzes its total sales for all its products. This is the original filter context. Once this calculation is completed, the company needs to explore its data in more granular detail by identifying how many bicycles it has sold. It can combine the original total sales measure with a new bike sales measure that generates insights into how many bicycles have been sold. So, the filter context changes from all products to all bikes. Before you review some examples, let's review the syntax of the calculate function. The calculate function can be invoked with an expression as its first argument. A set of filters in square brackets then follows the expression. These filters are defined or modified by expressions. To find out more about how this works, let's explore how AdventureWorks make use of the function. AdventureWorks first needs to calculate its total sales. The company can create the total sales measure using the SUMX function. The measure must multiply the sales table quantity and unit price columns. This measure uses row context and iterates over each row of the sales table to compute the total sales of products for AdventureWorks. AdventureWorks can continue to use this measure in all the other calculations it needs to complete. Now that AdventureWorks has a generic measure of total sales, it can refocus its filters to generate insights into bike sales. AdventureWorks can create a new measure called bike sales that uses calculate to analyze the sales of products in the bikes category. When the category bikes is executed, the formula calls the total sales measure again. However, this time it adds the bikes product category as an additional filter in the filter context. In other words, the filter context changes from all products to all bikes. Next, AdventureWorks needs to analyze all blue-colored products in each category. The company can write a new measure called sales of blue products. When executed, the expression incorporates the blue color from the product color column as an additional context for this calculation. It calculates the total sales of blue color products from the entire dataset. You can also specify multiple filters in the same calculate function. All the filters intersect regardless of the order in which they appear. For example, AdventureWorks can create a measure called sales of blue products in USA that computes the total sales of blue products in the USA region. This measure calculates the total number of blue products sold only in the United States by adding the country column from the region table in the overall filter context of the calculation. But what if you've already created filters on these columns? Any existing filters will be overridden by those in your calculate function. So, how do you retain both sets of filters? You can use calculate modifiers to keep the behaviors that already exist in your columns. An example of a calculate modifier is keep filters. You can add keep filters before your argument while placing the argument in parentheses. This ensures that existing active filters on your columns are not overridden or merged with new filters. Other examples of calculate modifiers include cross-filter, all, and use relationship. You'll explore these modifiers in more detail later in this lesson. You should now be able to use the calculate function to alter the filter context of your measures. So, you can create measures to generate insights into your data and modify your measures filters to ask and answer other questions about your data. As a data analyst, unlocking fresh insights requires exploring data from multiple angles. With role-playing dimensions, you can explore your data from different perspectives and eliminate the need for redundant data structures through active and inactive relationships. In this video, you'll explore the concept of role-playing dimensions and active and inactive relationships. AdventureWorks receives thousands of orders from all over the world, and it's important that the company continually analyzes its orders to avoid delayed or mistaken deliveries. It can use multiple dimensions to explore its order-related data from multiple angles. Let's find out more about role-playing dimensions by exploring how AdventureWorks makes use of it. In the context of Power BI, dimensions represent the various attributes or business entities used to organize data. Role-playing dimensions are instances of the same dimension, used multiple times in a data model. Each instance plays a unique role by representing different aspects of the data. This provides the flexibility to analyze data from different viewpoints without duplicating data tables. Let's demonstrate this with an example from the AdventureWorks database. AdventureWorks sales and shipping departments operate in sequence. First, new sales are recorded in the sales dataset as order date. Then the order's shipping date is recorded in the sales dataset. Finally, the system automatically generates a delivery date when the customer receives the product. So, in AdventureWorks sales dataset, the date dimension is used 3 times for new sales, shipping dates, and receipt dates. AdventureWorks can analyze sales performance by order and shipping date without needing separate tables, optimizing delivery time by delivery date analysis. This helps the business to analyze sales performance based on order date and shipping date without creating separate tables for each date type. When AdventureWorks queries its data, the role of the date dimension is based on the fact column used to join the tables. For example, the table join relates to the sales order date column when analyzing sales by order date. An important part of role-playing dimensions are active and inactive relationships. An active relationship is a relationship between 2 tables used for analysis, reporting, and visualization. An inactive relationship is a valid relationship, not being actively used in the current analysis. To differentiate between active and inactive relationships, Power BI marks active relationships with a solid line and inactive relationships with a dotted line. Let's examine an example from AdventureWorks. In the AdventureWorks table, the date and the sales tables have 3 relationships. However, there can only be 1 active relationship between 2 Power BI model tables. All remaining relationships must be set to inactive. A single active relationship means there is a default filter propagation from the date to the sales table. The active relationship is set to the most common filter used by the company's reports, which is the order date relationship. You can utilize the inactive relationship for specific analytical needs using the DAX use relationship formula. So, how do active-inactive relationships relate to role-playing dimensions? Here's a quick demonstration of how these concepts function in the AdventureWorks database. Let's begin with creating a role-playing dimension. After importing sales and date tables, you can create 2 relationships between them, one for order date and another for shipping date. By default, the first relationship is active and the second is inactive. The date table serves as a role-playing dimension for both order and shipping date. Any analysis, reporting, and visualization you require can make use of this active relationship. Occasionally, you'll need to analyze data from a unique perspective. For example, AdventureWorks needs to calculate its total sales based on the shipping date. However, the shipping date is an inactive relationship, so using this calculation requires a measure. To create such a measure, an inactive relationship needs to be employed. This is where the DAX function useRelationship comes in. To use the shipping date, the inactive relationship, create a measure using useRelationship. For instance, to calculate the total sales based on the shipping date, you can create a DAX formula. Calculate is used here to alter the filter context of the entire measure. Sum is summing up the sales amount column of the sales table. As the sales table is connected to the date table via order date column by default, each DAX calculation is based on the relationship between the tables. useRelationship function in DAX overrides the relationship and establishes a temporary relationship based on the shipping date column of the sales table, or inactive relationship. The relationship becomes active only for the current calculation. This formula forces Power BI to use the inactive shipping date relationship for the calculation. Role-playing dimensions and active-inactive relationships in Power BI create an efficient data model for comprehensive analysis. Although it might take some time to get used to these concepts, they will prove invaluable as you navigate your Power BI journey. As a data analyst, you'll often encounter table relationships that are difficult to perform analysis with. Fortunately, you can alter or manipulate table relationships to facilitate more efficient analysis using the useRelationship function. Over the next few minutes, you'll explore the useRelationship function, its syntax, and its application. AdventureWorks needs to analyze its sales data based on the shipping date. It could create a calculated table for the shipping date and relate it to the sales table. This might work well for a smaller dataset, but AdventureWorks has millions of shipping records. A more effective approach is for AdventureWorks to use the useRelationship function to create a measure that utilizes the inactive relationships between the tables. Before we explore how AdventureWorks can analyze its sales data, let's find out more about the useRelationship function. The useRelationship function is used within the calculate function. It forces the inactive relationship between the tables for the considered calculation to be used. This lets you switch contexts within your data model without changing the default relationship between the tables. It's most useful when there are multiple relationships between two tables. The function allows you to create context-aware calculations that can analyze data based on different date dimensions or adjust analysis based on a different category of products. The advantage of useRelationship is that it enables you to perform analyses using different relationships available between the related tables without affecting the overall structure of the data model. Now that you've explored how the useRelationship function works, let's review the syntax. Begin with the function and then place your argument in parentheses. The argument is the names of the required tables and their respective columns that define the relationship. The order of the columns doesn't matter for the accurate calculation. This function doesn't return a value, but modifies the context of a calculation. This changes the table relationships, meaning that there is no scalar value or table returned as a function is executed. Instead, it changes the context by overriding the relationship between tables. Let's return to AdventureWorks data model to explore the syntax in action. As you discovered earlier, AdventureWorks data model has a sales fact table and a date dimension table. The data model's current active relationship is from the sales table's order date column and the date table's date column. As no shipping date dimension table exists in the data model, AdventureWorks needs to create an additional relationship between the sales fact table and the date dimension table using the sales table's shipping date column. By default, the active relationship for any analysis and visualization is utilized. However, there may be a requirement to calculate the total sales using the shipping date. To do this, it can use the useRelationship function within the calculate functions. First, AdventureWorks creates a sales by shipping date measure. Then it inputs the calculate function, followed by the required argument in parentheses. In this argument, the sum expression calculates the total of the sales amount column from the sales table. The useRelationship function changes the context of this calculation by switching the active relationship from the sales table's order date column and date table's date column to the sales table's shipping and date to sales shipping date and date. When executed, this calculation results in multiple relationships between these tables, an active relationship with the order date and an inactive relationship with the shipping date. This affects only the calculate function where it's used. It won't permanently alter the active relationship. Let's review some important points to remember when working with useRelationship. useRelationship only works within the calculate and calculate table functions. If you try to use it elsewhere, you will receive an error. useRelationship functions can be used multiple times within a single calculate function to switch multiple relationships. The useRelationship must exist in the data model, but it doesn't have to be active. The useRelationship function provides flexibility to derive insights from different perspectives within a data model. This provides a layer of flexibility to Power BI, making it an essential function for data analysts to master. By now, you should be familiar with methods for generating insights into your data, but the most powerful and effective data insights you can generate are time-based. In this video, you'll explore the concept of time intelligence and discover its importance by reviewing some scenarios where it can be applied. Over at AdventureWorks, the company is preparing its sales strategies and marketing campaigns for the year ahead. As part of its preparation, it needs to generate insights into time-related data, like seasonal trends, annual growth, and specific sales periods. AdventureWorks can generate insights into these time-related aspects of its business by using time intelligence functions. As the AdventureWorks scenario suggests, time intelligence functions refers to methods and processes that aggregate and compare data over time. Data analysts can deploy time intelligence functions to analyze data based on time-related dimensions. Time-related dimensions include dates, weeks and months, and quarters and years. You can also generate comparisons of time-related data over annual periods and year-to-date, or YTD. So why do data analysts view time intelligence as important? Time intelligence provides the ability to analyze data within the context of time. This enables a more in-depth understanding of trends and patterns. As the earlier AdventureWorks example demonstrates, this data plays a significant role in a business's ability to generate insights to help with its planning, forecasting, and decision-making processes. Let's explore a few other benefits of time intelligence. Time intelligence is useful for trend analysis. Identifying trends in past business performance is crucial for future decisions. For example, AdventureWorks can use time intelligence data to examine historical sales trends and recognize if certain products sell better at specific times of the year. Identifying trends in past business performance is crucial for future decisions. Insights derived from time intelligence also help with forecasting and predictive analysis. AdventureWorks can forecast future trends and plan activity based on historical trends. It can make informed predictions about sales and demands, which helps with resource planning, budgeting, and risk management. For instance, if the data shows a consistent increase in mountain bike sales every spring, the company can ensure adequate inventory before the season starts. Time intelligence also enables real-time performance monitoring. This is possible by creating dynamic measures like year-to-date or YTD and month-to-date or MTD. AdventureWorks can use these measures to monitor real-time performance against key performance indicators. The company can then use these insights to respond quickly to changing conditions. Time intelligence calculations facilitate comparative analysis. An example of this is year-over-year or YOY functions. AdventureWorks can compare its current growth rate, sales performance, and other metrics against data from previous years to analyze its progress. Time intelligence also facilitates the optimization of sales and marketing strategies. AdventureWorks can analyze its sales trends and the impact of its marketing efforts over time. It can then use the results of these analyses to fine-tune its marketing strategies and sales tactics to improve its results. Now that you know its benefits, your next question might be, how do I use time intelligence? Implementing time intelligence involves creating calculated fields and measures to analyze data over time. You can use Power BI's automatic time intelligence features or deploy DAX formulas to create quick measures. Power BI offers an auto date time feature that allows easy data analysis by year, quarter, month, and date. This is useful for smaller data models. Power BI automatically creates one date table for each date column in the date model to analyze data by different date attributes. This table is hidden from the user because Power BI handles it automatically. You can also use custom DAX calculations to shape your data model and implement time intelligence calculations with more complex and non-standard requirements. Time intelligence is essential for understanding and visualizing time-related trends and patterns in data. As a Power BI developer, mastery of time intelligence calculations is key to generating meaningful information from your data. Meet Tina, AdventureWorks in-house expert on using time intelligence calculations in DAX. AdventureWorks is looking to optimize all aspects of its business, from sales and deliveries to financial planning using time intelligence calculations in DAX. The company suggests that Tina analyze its data in these areas and generate insights that reveal where improvements could be made to the business. First, Tina focuses on sales. She performs time-based trend analyses using year-to-date functions to analyze trends and patterns in sales over time. Her analyses reveal seasonal spikes and downward trends in sales of certain products over different months and quarters. AdventureWorks can use these insights to forecast demand for its products. This means the company better understands what products customers purchase and when they will most likely buy them. It can design and implement marketing strategies targeting consumers during the months they're most likely to purchase specific products. Tina's insights into sales trends also help AdventureWorks to manage its inventory better by identifying what kinds of bicycles customers are likely to buy and when. AdventureWorks can then ensure that these products are in stock in time for busy sales periods. Tina can also use time intelligence functions to track sales team performance. She can compare current and past performance data to prepare for the upcoming sales period. The insights generated from her comparisons are then used to set realistic targets for the team and identify the high performers. The upcoming sales period also requires large investments in inventory and marketing. Fortunately, time intelligence is also a useful budgeting and financial planning tool. Tina can compare actual financial data with budgeted values over different periods, assess financial performance, and track spending. The company's finance team can use these insights to make budget adjustments. Time intelligence functions can also identify issues and their root cause. For example, AdventureWorks anticipated a high volume in sales of mountain bikes over the holiday sales period, but sales declined over the season. Tina can use time intelligence functions to drill into the related data and isolate these sales anomalies to analyze the root cause of the slowdown in sales. For example, the decline in sales might indicate a shift in customer behavior that needs to be addressed. Time intelligence in Power BI is an important tool that businesses can use to use the power of time dimensions in data analysis. Through the insights generated by time intelligence, businesses like AdventureWorks can generate valuable insights that drive informed decision-making and help resolve issues. Congratulations on reaching the end of the second week in this course on data modeling in Power BI. This week, you've explored how to use data analysis expressions, or DAX, in Power BI. Let's take a few minutes to recap what you've learned in this week's lessons. You began the first lesson by learning about DAX. DAX is a programming language that adds new information about existing data. It consists of a library of functions, operators, and constants. These are used in formulas or expressions to add information missing from the original data model. A key element of formulas is functions. Functions are reusable logic used in a DAX formula to perform tasks like aggregation or calculations. Commonly used DAX formulas and functions include calculate, sum, and average. You then explored the syntax of a formula. A formula begins with the name of your new calculated column or table, followed by an operator, typically an equal sign. You then write the name of your DAX function and parentheses that contain the logic of your formula. You then learned about row and filter context. DAX computes formulas within a context. The evaluation context of a DAX formula is the surrounding area of the cell in which DAX evaluates and computes the formula. Row context refers to the table's current row being evaluated within a calculation, while filter context refers to the filter constraints applied to the data. This determines which rows or subsets should be included or excluded from the calculation. You are then introduced to calculated tables and columns. A calculated table is a new table created within a data model based on data from different sources. A calculated column is a new column added to an existing table that presents the results of a calculation. You then completed the lesson by putting your new skills to the test by assisting AdventureWorks with its use of DAX in the exercise and completing a knowledge check. In the second lesson, you received an introduction to measures. You learned that a measure is a calculation or metric that generates meaningful insights from data. Measures are an important aspect of data analysis and play a lead role in creating calculated tables and columns. There are 3 different types of measures: additive, semi-additive, and non-additive. Which type of measure is used depends on the needs of your data and its dimensions. A key element of measures is statistical functions. Statistical functions calculate values related to statistical distributions and probability to reveal information about your data. Several common statistical functions are used in measures like average, median, and count. You learned how to build statistical functions into your syntax and explored how to use common functions, like using the average function to calculate the average of a dataset. You then discovered how context impacts DAX measures. You reviewed AdventureWorks business scenarios in which the context of measures influenced the company's business decisions. Finally, you tested your new skills with a knowledge check and explored additional learning material in the additional resources. In the 3rd lesson, you expanded your understanding of measures. You began by learning how to create quick measures in Power BI using common calculations instead of DAX codes. You then explored techniques for creating more complex custom measures with DAX. Next, you learned how to use the cross-filter function. You can use the cross-filter function to change the cross-filter direction between tables for a specific measure while maintaining the original table settings. A cross-filter function can only be used with a DAX function that accepts a filter as an argument, like calculate. You can use calculate and its related modifiers to combine filters and generate more granular insights into your data. You then tested your new skills by adding a measure to an AdventureWorks dataset in the exercise. And you tested your understanding of the topics in a knowledge check. In the 4th lesson, you explored how DAX is used with table relationships. You began the lesson by learning about role-playing dimensions, instances of the same dimension used multiple times in a data model. Each instance plays a unique role by representing different aspects of the data. This allows analysts to analyze data from different viewpoints without duplicating data tables. In a data model, relationships between tables are either active or inactive. You can configure these relationships using the useRelationship function alongside the calculate function to force the use of the inactive relationship. You completed this lesson by helping AdventureWorks to add a role-playing dimension between 2 tables in its data model. You then tested your understanding of the topics in a knowledge check and explored further learning material in the additional resources. In this week's final lesson, you explored time intelligence in DAX. You learned that time intelligence functions refer to methods and processes that aggregate and compare data over time. These functions can be used in Power BI through the AutoDate time feature or DAX. DAX can summarize data over time by identifying trends, patterns, and anomalies over a specific period. Or it can be used for comparison over time by comparing data sets over specific periods. These insights are generated using summarization and comparison functions that return the required insights. There are also more complex functions that can be used with time intelligence. A prerequisite for using time intelligence functions is a common date table or date dimension. If this isn't present in your data model, you can build one using the calendar function or the calendar auto function. Both functions return a calculated table with a single date column and list of date values. You also learned how to generate a calculated date table using IM language in Power Query. You then explored a real-world scenario where time intelligence played an important part in a business's decision-making process. During this lesson, you helped AdventureWorks use time intelligence calculations in DAX during an exercise and activity. You've now reached the end of this module summary. It's time to move on to the discussion prompt, where you can discuss what you learned with your peers. You'll then be invited to explore additional resources to help you develop a deeper understanding of the topics in this lesson. Best of luck. We'll meet again during next week's lessons. Summarizing data over a specific period is a key skill for data analysts. Time-based data can generate temporal insights and trends within data. In this video, you'll review the importance of using DAX-based time intelligence functions to summarize data over time. Over at AdventureWorks, the company needs to generate insights into its recent sales trends. The insights it requires includes revenue growth, seasonal sales patterns, and the impact of marketing campaigns. AdventureWorks can generate these insights using time intelligence functions in DAX to summarize its data over time. So, what does it mean to summarize data over time? At its core, summarizing data over time is identifying trends, patterns, and anomalies in business performance over a specific period, like sales per quarter or annual growth. You can generate these insights by using time-based data summarization functions. Some frequently used examples of these functions include total year-to-date, and dates between. Each function generates insights into different aspects of your data. The functions are written by stating the function name and the required arguments in parentheses. This basic structure is similar across all functions, but the syntax for the arguments varies or must be combined with calculate and other functions. Let's begin with the year-to-date calculation. The year-to-date calculation, or YTD, aggregates values from the beginning of the year to the specified date. For example, all sales from January 1st of that year to the specified date. The year-to-date requires 2 mandatory and 2 optional arguments. Expression is the first mandatory argument. It calculates the total sales from the sales table. Dates is the date column. We use Power BI default date dimension in the current lesson. Filter and year-end date are optional parameters. For example, AdventureWorks wants to evaluate its real-time sales performance. Call the expression sales year-to-date and add the total year-to-date function after the equals operator. In your first parameter, reference the total sales column from the sales table and aggregate the values using sum. In the second parameter, reference the order date column from the sales table. Then add another date field in square brackets. When you type the date field, Power BI allows you to select a field from the table. Next, let's review the date year-to-date function. This function returns a running total in the form of a single column table containing year-to-date or YTD dates in the current filter context. This function is part of a group that also includes the dates MTD and dates QTD DAX functions for month to date, also called MTD, and quarter to date, or QTD. You can pass these functions as filters into the calculate DAX function. The syntax contains 2 arguments. The first is dates, the column containing the required dates, and the second is the year-end date, an optional parameter. While the total YTD function is simple, it limits the filter expression to only one filter. If you need to apply multiple filter expressions within year-to-date values, use the calculate function. Then pass the dates YTD function as one of the filter expressions. For example, AdventureWorks needs a running total that calculates its year-to-date sales on a month-by-month basis based on the order date column from the sales table. It can calculate this by creating an expression called sales year-to-date method 2. The expression does not refer to any separate date table. Instead, the dates YTD function is combined with the calculate function so AdventureWorks can incorporate further filters. When executed, the expression returns a calculated table with the required running monthly total. The next function is dates between. This function returns a table that contains all dates between a specified start date and an end date. The syntax contains 3 arguments. Dates is the column containing dates. Start date is the date expression for the start of the calculation. End date is the date expression for the last date for the calculation. AdventureWorks wants to evaluate its total sales over the summer season. So, it must create a measure using the dates between function in DAX. The DAX code computes the total sales between June 1st and August 31st, 2023. The calculate function computes the values of the total sales column of the sales table, and dates between defines the period for which the sales values are to be computed. When executed, the expression returns a calculated table with the required total sales figures. As these examples have shown, your data model requires a date table or dimension before you can use time intelligence functions. However, you can use Power BI's auto-date time intelligence if you're missing the date dimension. Or you can create a date dimension in Power BI using Power Query or DAX. As you just discovered, DAX-based time intelligence functions provide valuable flexibility in summarizing and analyzing time-based data. You can use these functions with other DAX functions to build powerful and insightful data models. As a data analyst, it's important to be able to compare datasets, particularly those from different periods, like previous years or months. In this video, you'll learn how to use DAX for comparison over time using time comparison functions, like dateAdd, parallel period, and same period last year. AdventureWorks is preparing its marketing campaign for the holiday season. As part of its preparations, it needs to analyze and evaluate campaigns from previous years. AdventureWorks can implement DAX time intelligence comparison functions to identify trends and patterns from marketing campaigns from previous years. It can then use these insights to inform its current campaign. Before you can help AdventureWorks, let's find out more about comparison over time. Comparison over time means, as the term suggests, comparing sets of data over specific periods. For example, comparing sales from this month to last month. These comparisons are generated using time intelligence functions in DAX like same period last year, dateAdd, and parallel period. The basic syntax for each function is to state the function name followed by the required arguments in parentheses. However, the rest of your syntax can vary according to the function's requirements and your analytical needs. When executed, the functions return insights in the form of a table. Let's explore an example of each function from the AdventureWorks database to learn more about how they work. The same period last year function returns a table that contains a column of dates. These dates are shifted 1 year back in time from the dates in the specified dates column in the current context. In other words, it compares the current period against the same period from last year. The syntax for this function requires one argument in the form of specific dates. AdventureWorks can use this function to evaluate its sales from the previous year to compare them against the sales team's performance from this year. It first creates a measure called revenue previous year. Then it defines var as the variable for the previous year's revenue. Calculate computes the total revenue based on the same period last year function, which takes the date column from the sales table as its parameter. In this instance, we are using Power BI's auto-generated date dimension. Finally, the return function displays the value of the entire expression. Next, AdventureWorks wants to evaluate its year-over-year change in sales. It can modify the measure it just created to calculate the change ratio. It first creates a new measure called revenue year-on-year percentage. Variables used in the expression enhance the code readability and query performance. And in addition to the previous calculation, the divide function computes the change ratio of sales amount by dividing the difference by the previous year's revenue. The results of both measures can be visualized in table format. The following table extract compares revenue for July and August over a 3-year period. Next, let's look at the dateAdd function. The dateAdd function returns a table containing a column of dates, added either forward or backward in time by the specified number of intervals from the dates in the current context. The syntax contains 3 arguments. Dates is the column containing the required dates. The number of intervals is the integer value that defines the number of intervals to add or subtract from the date. Interval is the unit of time by which to shift the date. The unit can be a year, quarter, or month. For example, AdventureWorks can use the dateAdd function to compare this month's sales with the previous month's sales. The calculate function computes the total revenue based on the filter arguments previously computed in the revenue measure. Date add function takes the order date column from the sales table as a date reference. 1 represents the unit of time, and the negative sign indicates that the intervals are back in time. Month represents the unit of time. You can also use day, quarter, or year. The results of this measure can be visualized in table format. The following table extract compares sales revenue for August to October over a 2-year period. Comparing data over time is a powerful method for deciphering business trends and growth patterns. Mastering this skill will enable you to provide valuable insights for your organization to help it strategize and grow.